Our last chapter in our search for AP Chemistry success, Chapter 20, dealing with electrochemistry, obviously dealing with the electricity, sometimes involved in chemical reactions. So we're going to start off with section 20.1. I believe there's 6 different note sections or 7 different note sections from this chapter. Not too bad of a chapter, a little bit more difficult than chapter 19, which is probably the easiest chapter all year. This one is fairly easy as well, not too difficult. So let's start off here. Let's see. Alrighty. So we're going to talk about what are called redox reactions. We're going to talk about things that have been oxidized, reduced, and all that. This first section should be a brief introduction or review of what we've talked about already. So oxidation reduction reactions deal with the gaining and losing of electrons. Okay, if you remember back from chapter 4, oxidation deals with the loss of electrons. Remember the whole oil rig. Oxidation is losing electrons, and reduction is gaining. So when you lose electrons, when something loses electrons, it's being oxidized. When something is being reduced, it is gaining electrons. Okay, in an oxidation reduction reaction or in a redox reaction, something has to lose electrons and something must gain electrons. If there's nothing that gains the electrons, then something can't lose electrons, and it's not a oxidation reduction reaction. In this case, as you can see, the zinc is going from a charge of 0, it's in its elemental form, to a charge of +2. When it goes from a 0 to a +2 charge, it means it has lost 2 electrons. Therefore, zinc is being oxidized. Hydrogen is going from a +1 charge to its elemental form, which is a 0 charge. So therefore, hydrogen is being reduced. Okay? Now, if something is oxidized, again, zinc is oxidized. If something is oxidized, we call it the reducing agent because it allows something else to be reduced. Don't get those two things mixed up. So the things that mean the same, if something is oxidized, we say that it is the reducing agent. Look at my cursive, huh? The reducing agent. Another way they sometimes call it, they also call it the reductant. Just different ways to confuse you. All three of those things mean the same thing. So if something is oxidized, it's the reducing agent, or it can also be called the reductant. Okay. Likewise, if something is reduced, we call it the oxidizing agent or the oxidant because it allows something else to be oxidized. Okay. Now, when electrons are transferred, energy can be produced in the form of electricity. And that's what this chapter is about. It's about oxidation reduction reactions where electrons are transferred from one thing to another and thereby producing electricity. Okay, first of all, we need to talk about how we know if an oxidation reduction reaction is occurred. Okay, and it's real simple. If one thing loses electrons and the other thing gains those electrons, then we call it a redox reaction. Okay, and we simply just have to keep track of the oxidation numbers of all the elements that are involved in the reaction. Okay, the way we do that is we have our set of oxidation number rules. Okay, rule number 1 tells us that the oxidation numbers of all the atoms add up to the charge on the molecular ion. So if you have SO42- sulfate, the sulfate ion, it must add up to -2. If an atom or element is in its elemental form, its oxidation number, and remember when we say oxidation number just means the charge. That's the fancy way of saying what's the charge on it. So when we say an atom in its elemental form has an oxidation number of 0, it means its charge is equal to 0. We know that alkali metals have an oxidation number or a charge of +1. Alkaline earth metals are +2. and then the boron aluminum group is plus 3. Okay, and here's where it starts to get a little bit trickier. Not really, though. This isn't too hard. When hydrogen is with a nonmetal, such as in H2O, it has a charge of plus 1. When hydrogen is with a metal, such as NaH, sodium hydride, it has a charge of negative 1. Okay, and then also the oxidation number of fluorine is negative 1. Okay, we'll talk about why that seems kind of a random place to put it. We'll talk about why that is here in just a second. Okay, oxygen in general has a charge of negative 2 unless you have a peroxide such as hydrogen peroxide, where the hydrogen is plus 1, therefore the oxygen must be minus 1. And then rule number 6, which comes after rule number 5, is that halogens are minus 1. Notice that fluorine is right here. It is a halogen. Why would they put that here instead of down here with rule number 6? Basically because right here, this is a hierarchy, which means you follow the rules in order. If two things conflict, you follow the rule that's above. So if you have, for example, OF2 compared to OCl2, in this case, the rule for fluorine being minus 1 comes before the rule that oxygen is minus 2. So therefore, fluorine is minus 1. Oxygen therefore must be plus 2. In this case, though, of the OCl2, the oxygen rule is rule number 5. The chlorine rule is number 6. Therefore, oxygen is minus 2, and the chlorine is plus 1. So it depends on the order that it comes in. Okay, so our last two rules, the halogens are minus 1, and the ones in the oxygen group are negative 2. Again, notice the position of those rules. Okay, so here's an example of 5 different compounds that have sulfur in them. We need to be able to look at those compounds and determine what would be the charge on sulfur in these compounds. So on A, we've got H2S. H2S hydrogen is with a nonmetal. If we come back to our rules, rule number 4, it is plus 1 with nonmetal. So therefore, hydrogen is plus 1. That means sulfur must be negative 2. In this case, sulfur is all by itself. That must be its elemental form. Therefore, it has a charge of 0. Okay, letter C, sulfur is with a halogen. The rule is that I can't remember the number, but the rule for the halogens comes before the rules for the oxygen group. So therefore, chlorine is minus 1. That means sulfur must be plus 2. Okay. Letter D, oxygen is minus 2, and there's 3 of them. So that means the oxygen part is negative 6. There's 2 sodiums. Those are both plus 1, so that's plus 2. And we have to get the whole thing to 0. So negative 6 plus 2 gives us negative 4. Therefore, the sulfur part, to get it back to 0, must be positive 4. And then our last one, oxygen is minus 2, and there's 4 of them, so that makes a total of minus 8. But we're not getting back to 0, we're only getting back down to negative 2. So if we're at negative 8 due to the oxygens, then the sulfur must be plus 6. Okay, so there are those. So you can see that in different compounds, one chemical, such as sulfur in this case, can have a huge change in its oxidation states or its charges. Okay, here's a couple other examples. Here we've got P2O5. They want to know the oxidation state of the bold-faced element. So in this case, we're looking for the charge on phosphorus. Oxygen's minus 2, and there's 5 of them. That makes it minus 10. Therefore, the phosphorus must be plus 10. But since there's 2 of them, it must be plus 5. Here, the sodium is plus 1. Therefore, the hydrogen must be minus 1. Here, again, the oxygens are minus 2, and there's 7 of them. So that gives us a total of minus 14. We have to get back not to 0, but to negative 2. So this whole thing part here has to be positive 12. And since there's two of them, each of them are going to be positive 6. In tin bromide, tin 4 bromide, bromine has a charge of -1. There's 4 of them. That means tin has to have a charge of +4 to get it back to 0. And then in BaO2, we know in this case it should just be BaO because of the charges, but in this case it must be a peroxide. So therefore, oxygen's -1. There's 2 of them, so barium must be +2. Yeah, you wouldn't have BaO2 unless barium has to be +2, right? Come back here. Yeah. The rule for barium, an alkaline earth metal, comes before the rule for oxygen. So therefore, if they want to know the charge on barium, they want to know the charge on oxygen. I'm sorry. Oxygen is the bold-faced one, so barium's +2, so each oxygen right has to be -1. Sorry. A little slow. You'll get over it. Okay, so now we take that information and now we start looking at chemical reactions. Okay, this is definitely something that will appear on the AP exam where they'll give you a reaction like this and that you have to be able to determine what's being oxidized and what's being reduced in this reaction. The charge on chlorine, it's in its elemental form, 0. Charge on iodine, -1. Charge on chlorine, -1. Charge on iodine, 0. So chlorine is going from a 0 to a -1 charge. Remember, if it's negative, it had to have gained electrons. It had the same number of protons as electrons here, because it's neutral, and now it has a charge of -1. It means it had to have gained an electron. So that means chlorine had to be reduced. Iodine goes from a -1 charge to a 0. That means it lost an electron. So therefore we say that iodine is being oxidized. Remember, oxidation is losing electrons, oil rig. Chlorine is being reduced. Okay, now in this reaction, this is much more difficult, but we have to do the same thing. We have to basically go through this whole reaction and determine what's the charge of each one on both sides. Hopefully right away you can see that iodine, here it has a -1 charge. Here it's in its elemental form, so it's going from a -1 to a 0 charge. If it's going from a -1 to a 0, here it was negatively charged, now it lost its negative charge. So iodine has to be losing electrons. If it's losing electrons, it's being oxidized, so we know the iodine is being oxidized. If it's being oxidized, then it is the reducing agent. Okay? The hydrogen, here it's +1, over here it's still +1. Oxygen's -2, over here it's still -2. The manganese, though, here -2 times 4 is -8, and we have to get back to -1. So the manganese has to be +7. Over here we can see that manganese is +2. So it's going from a +7 to a +2. So it's getting closer to becoming neutral from the positive end. So therefore it has to be reduced. It gained 5 electrons. Therefore it is the oxidizing agent. And I'm sure when I click the button, all this is going to disappear and it's going to say what I just said. Yes. Okay. So there it is. Okay. So here's another reaction. Here we've got H2O, and usually hydrogen and oxygen aren't the ones that change their charges. Usually it's like in this case, probably going to be the aluminum and probably the manganese. Let's take a look and see. The charge on aluminum when it's by itself, it's just its elemental form, so it's 0. Here it's OH4. Hydroxide has a charge of -1, and there's 4 of them. So that's -4. We got to get back to -1, so here the aluminum is going to be +3. Okay. In this case, the oxygen's -2. There's 4 of them. So again, the manganese has to be +7 because this whole thing here is -8. -8 plus 7 gives us our -1. Here, the oxygen's -2. There's 2 of them, so that's -4. So the manganese has to be +4. So the aluminum goes from 0 to +3 The manganese goes from +7 to +4. Okay, and then you got to think of which of those is being oxidized, which is being reduced. If you go from 0 to +3, that means you've lost 3 electrons. That means that aluminum has to be oxidized. If aluminum is oxidized, then again it is the reducing agent. So aluminum is the reducing agent. Manganese is going from +7 to +4. It's becoming more neutral. To go from +7 to +4, here it has 7 extra protons. Now it only has 4 extra protons. It means it had to have gained electrons. If it gained electrons, then that is reduction. If it's reduction, then it has to have been the oxidizing agent. Okay. So wrapping that up, electrochemistry, we're going to talk about electricity and how it relates to chemical reactions. Redox reactions involve the change in oxidation state. Remember, oxidation state just means the charge on the ion or the substance. And remember that oxidize means the reducing agent. If something's reduced, it's called the oxidizing agent. Have fun with that, huh? So out of the book for 13 and 14, along with answering the question that they have in the book, also tell me what's being oxidized and what's being reduced. And then from the review packet, do number 10 as well.